understanding purpose I'm giving. Okay, this is what we know. Cathode. Okay, this is accelerating potential. $10,000 volt. Okay, here is the radiation incident. No. Okay, definitely shall we call this is like a cathode which will collect, and the ejected electrons will be here. How the electric field, I think we have one method no to in showing that electric field, that this will be the direction of E bar will be in this direction. How do we can say that E bar is due to applied accelerating potential? Kmax is here, nearby. Kmax is nearby the plate. And what is the formula? Kmax equal to hc by lambda minus work function. That's also available. What is the power supplied by accelerating voltage? Okay, try to read all the things. We're mixing up X-rays with photoelectric effect. Little bit. Both ideas is mixing up that one. Okay, let's come for one by one. Work function of what? Work function of this. So right nearby, if you find a little bit difficult, 10 electron volt. Okay, the Kmax, can we write anything? Kmax equal to SC lambda work function. So this much what we have. Monochromatic radiation of wavelength and power 100 watt is incident on emitter. This is the emitter. Within 2 minutes, we'll end up this question. Only thing we have to understand. If you understand, it's very easy. What he is telling. So we have this power 100 watt. What to do with this? And we have efficiency. So first we calculate number of photons incident on the emitter. Let's go back to the basics here. Number of photons incident on emitter per second. That is Ni, I'll write it. So this should be equal to power by SC lambda. Per second, number of photons incident on emitter per second. With a quantum efficiency of 1%. For every, look at these many photons that are incident, okay, we have 1% is there. So number of photo electrons ejected, number of ejected per second. Shall we write this 1% into Ni? So that eta quantum efficiency. Eta, I'll write it symbol. I think everywhere we use the same symbol, no? So this should be 0.01. Or if you want, you can just read. Later on, you can substitute all the formula. Let me explain. Okay, this is what number of photo electrons that are ejected by the plate per second. These electrons, what happen? They will pass through it. No, these electrons, by the time they come here, they will strike the collector with a kinetic energy. Can we calculate this K? Okay, I think whether it's needed or not, plus charge of electron E into VA. Is that okay, no? Okay, because this is needed. This what the kinetic energy with which the electrons will go and strike the collector. Collector is tungsten target. Yeah, because this is also needed. You can see what is the power supplied by the accelerating voltage source. What do you mean by that? How to bring that one? And because of this, a saturation current will flow. High saturation, I'll write it. How to calculate this? Shall I multiply just with charge of electron? Will I get saturation current? Any with, because what is any? Those many electrons are emitted, those many electrons are going to strike the tungsten target per second. Into charge, if I put it, they'll become rate of flow of charge, there'll be current. So what is I saturation? I saturation should be equal to charge of electron into any. So now what is the power? Power of the power supplied by the accelerating voltage source. PA, I'll write it. The first part I'm discussing. That should be equal to accelerating voltage into I saturation. Okay. That's the first part of the problem. I think, what is the option given? Comprehension 7. 100 watt is telling. Huh? Check the calculation. You'll get it. Okay, next after that. The minimum wavelength of radiation coming from tungsten target. From where the tungsten target? Why that radiation should come? There's a light. There's a radiation incident on the platinum emitter. Incident radiation. Okay, now is asking next part. So we know if a fast moving electrons, if they strike a metal, then what happens? We'll get X-rays, no? Okay, these are X-rays. Agree this. So what are the minimum wavelength of radiation coming from tungsten target? Minimum wavelength. How to bring that? I think that's what this K needed. Huh? So this is the second part of problem. So what is, we know this K should be equal to HC by, this K should be equal to E into, okay, this, okay, I think, yeah, this much, HC by lambda. So where this cutoff wavelength, I think we use symbol lambda, not something. Different symbols, please do try to understand here. Okay, this is a cutoff wavelength. Okay, fine. So this is, I think, substituting all the values, what all we know. So we'll end up with the required answer. So even option 1, you are unable to think in exam, you can do the 2. Able to understand? So sir, like I'm not getting what is the meaning of this. At least try this. That's what you see. In comprehension, that's what you have to do it. If there are 3 questions are there, at least are you able to do to at least even any one sufficient in the last moment. Sometimes maybe sometimes instead of numerical, maybe some information based, theoretical, attempt that and come. Who will scold you that why you attempt, why you could not attempt the other 2? Nothing like that. No, there's no punishment for that. Please be alert in, and you should use all the tricks to gather marks. You should be like a wolf. In exam what pen, you should not be like a tiger. Huh? You should not be tiger. You should be like a wolf, very cunning. Then only what happen, you will do better. Tiger, okay, you're good knowledge, but wolf, what happened? Though having less knowledge, okay, less strength, but still what happened? It will survive very easily compared to tiger. So what happened? The wolf nature is what needed in exam, not the tiger nature. Okay, let's come for third one. If the source of monochromatic radiation of wavelength has an efficiency of 50%, tell me like where you are going to change. Third one is very important. It's trying to drag you to some other idea now. Okay, this we know it. You can see the third part is really making you to think very hard. If the source of monochromatic radiation of wavelength has an efficiency of 50%, what do you mean by 50%? Of all the incident light energy, 50% of that will be converted as an efficiency of 50%. It's not a 50%, as an efficiency of 50%. And the power of X-ray emitted by the tungsten target is, this X-ray is having 3 watt. This, what is the power of the source? Okay, that already we know. Power of exciting potential is how much? 100 watt, this will power. 3 watt is what available here. Efficiency 50% means what? Same condition for the same saturation current. The way he's asking question. If the source of monochromatic radiation has an efficiency of 50% and the power of X-ray emitted by the tungsten target is 3 watt. The overall efficiency of the apparatus for X-ray production is. If I stop this radiation, what will happen? We don't get any X-rays. So therefore, who are responsible for X-ray production? These two. So this is providing 100 watt. What about this? How much it should come with energy? 50% efficiency means it should come with how much? I think 100 watt is inside. It should come with 200 watt, no? Are you seeing 1%? When it is having 50% means what will happen? It should come with 200 watt. So the 200 watt plus 100 watt is what the supplied power. Output power is how much? 3 watt. That is asking here. So the third part. Overall efficiency is equal to total power of X-rays by power of incident radiation plus power of accelerating voltage. Okay, total power of X-rays 3 watt. That itself is given. Power of incident radiation. Shall I write 100, 50 or 200? Anybody? This we know 100. Power of accelerating voltage, PA. Shall I write 50, 100 or 200? Any value?
100.
No, it was select earlier. It was 100 watt. 50% efficiency means what? To have the same setup, to have the same conditions, it should come 50% efficiency means it was earlier incident with 100 watt. No, 50% efficiency means what? It should, to have that same saturation current, it should come with 200 watt. No. overall efficiency, into 100%. I'll write it. Zero 0.01 or 1%. Okay, no photoelectric effect and X-rays. Combined things can also be asked. Be careful. The cutoff wavelength is new formula is what you have seen. Are you noticing this? The new formula. Usually without this Kmax is what we have seen in X-rays. Because of photoelectric effect, we are taking this one. So at emitter here, so what photoelectric effect occurs, here X-ray occurs. And that's what here, the basic idea of the problem. I'll write note because I think at emitter, photoelectric effect occurs. At collector, X-rays are generated. Okay, I have junior class.